this chip could be inside your next gaming PC, or at least what it is based on. Today, let's talk about RISC-V ISA. What is it? Why does it exist? Can you even play games on it? And lastly, why should you care about it? RISC-V is an open source ISA, unlike x86 or ARM. Now, what is an ISA in the first place? ISA, or instruction set architecture, acts as an interface between your hardware and the software. These instructions defines operations such as arithmetic, addition, subtraction, logical operation, logical and, logical or, and data movement. Basically, it is the foundation that your system is built on top of. Now, these ISAs can be categorized into two different sections: CISC and RISC. x86 uses CISC and ARM and RISC-V uses RISC. And I have already made a video explaining the difference between these two. So if you want it, check it out right here or here, wherever it pops up. But what makes RISC-V so special that I am making a video about it? Well, as I said, it is open source. That means you can design your own chips and cores and start a chip design firm. If you want to design your x86 cores, you can't, because the x86 ISA is owned by Intel and the 64-bit extension on top of it owned by AMD, and they don't allow anybody but themselves to design on these architectures. With ARM, yes, you can use the core architecture, but you have to pay royalty to ARM on every unit that you sell. As an open standard architecture, no one owns RISC-V, but it is maintained by the member companies of RISC-V International, which includes Google, Intel, NVIDIA, Huawei, Sci-Fi, and more. Also, RISC-V is very flexible. It offers a simple and small set of instructions to the processor to accomplish various different tasks, and its optional extensions allows designers to build and customize a chip in a way that is completely tailored to their end application. But one thing to note here is, although the instruction set is open, that doesn't mean that the actual chip designs are open. There are some which companies and even you can use, but not all of them. And thanks to its modularity, it's already in use in a bunch of IoT devices and some major products from major companies. For example, Google, NVIDIA, and more, which I'm coming to in the later part of the video. But what is the performance like? And can you play games on it? If we compare the performance of RISC-V cores with its competition like x86 and ARMs, then the RISC-V cores' performance are, well, lackluster, for lack of a better word. Some profile cores like RVA22 performs and offers similar feature to Raspberry Pi 3, but with twice as many cores, and also Raspberry Pi 3 is definitely started to showing its age right now. And that's the thing, most RISC-V CPUs are not really available in the market, and even which are comes in a single board format, which means they are meant for developers, not really for consumers. Linus Tech Tips and Jeff Gerling tested or tried to play some games on some widely available and powerful RISC-V CPUs, and even with a decent enough GPU, they were just able to run the game, not really play it, unless you consider 0 to 4 FPS on Witcher 3 as playable. But that doesn't mean it is useless for us gamers. At least NVIDIA doesn't think so. In a recent RISC-V summit, NVIDIA have revealed that they are using from 10 to 40 different custom RISC-V chips on their products based on the chip's complexity. Now, they didn't ditch CUDA cores, so that's NVIDIA's bread and butter, but they have used RISC-V cores as MCUs. No, not that kind, but the microcontroller kind. Modern GPUs are highly complex SoCs with large number of functions, ranging from compute operations to display management and all the way to security. And for that, NVIDIA has designed and deployed these RISC-V cores. Think of them as a ball inside your ball pen. Without it, you can write, but having it really helped. RISC-V began as a project in UC Berkeley to create an open source computer, and from then and now it has came a long way. Yes, it is not as fast as its competition, but it really doesn't need to be. The biggest advantage of RISC-V is its flexibility and modularity. So a designer can design a chip that does what it needs to do, and exactly that. We might not see fully RISC-V based CPUs on our gaming PC anytime soon, but there might be some parts of that CPU are built using RISC-V ISA. And even now, RISC-V is actively being used in major applications from major companies. In wearables, smartphones, automotives, and data center. It is just one breakthrough away from being the talk of the town. Everyone thought that ARM can never compete with x86 and can never become a major player in HPC. But Apple proved a whole industry wrong with their M series chip. Now, this was a very non-technical overview of RISC-V. And if you want to know more about this architecture and this instruction set, I have linked down some resources which I will definitely encourage you to check it out. And while you're down there, why not like the video if you liked it, and leave a good comment if this video helped you. If it didn't, if I wasted your time, leave a dislike and leave a nasty comment. And if you want to watch more videos from us, check out this video right here. And if you want to subscribe, which I highly appreciate if you do it, well, do it by here. And there's Akash, and I will see you guys in the next one. Peace.